Hello everyone there. We are going to discuss some of the important concepts related to engineering mechanics as per placement point of views. What are the important points and chapters which we need to keep in mind while going through the placement interviews. This particular course is being divided in 4 chapters in which we will be dealing with the basic concepts and most of the questions which are being asked in placement interviews. Now it will be like in the first chapter we'll be dealing with basics and statics of particles, in which we'll be dealing with vectors and its addition and subtraction laws. Then we'll be dealing with the classification of forces and the theorems related to that. In the second part, we'll be dealing with the equilibrium of particles and rigid bodies and what are the conditions which are required for the equilibrium of the particles and the rigid bodies and the theorems related with that. In the third section, we'll be dealing with the moment of inertia, how to calculate the moment of inertia and what are the standard theorems related to the moment of inertia. And in the last part, we'll be dealing with the kinematics of rigid bodies, in which we'll be dealing with force, mass, acceleration and frictions and the laws related to that. So let's start, guys. The first one is forces and its classification. Now this classification is based on the line of action of the forces in which the forces are being applied and the plane, that whether the forces are being applied in the same plane or the planes are different. Now, second thing which we are going to see in this particular slide is a theorem which is based on static equilibrium, a Lamy's theorem, which is very important as per placement point of view. So we will be discussing that theorem in details. And the third thing is the vectors and its addition and subtraction and the laws governing its addition. Let's start with the classification of forces. Now, the first kind of forces is like concurrent forces. Now, concurrent forces are the forces whose line of action are same or that could be same when extended. In the figure, we can see that there are 4 forces F1, F2, F3 and F4 which is being applied at a point. Now, we can see that the line of action of these forces are same. So that's why these forces can be referred as concurrent forces. Now the second one is coplanar forces. When the forces are being applied in a same plane, the planes are not different. The forces can be referred as coplanar forces. The third one is a parallel forces. When the line of action never intersects, I repeat it, when the line of actions are never intersects, the forces are referred as parallel forces. Now this could be in a same direction or this could be in an opposite direction also. So here in the figure we can see that there are lots of forces being applied to a plane in the same direction and opposite direction, but their line of action didn't intersect. That's why this can be referred as parallel forces. Now the last type is collinear forces. Collinear forces are the forces whose line of action is same and in the same plane. So here we can see that the forces F1 and F2, when their line of action are being extended, they meet in a single line. That's why these forces are referred as collinear forces. Now we need to understand one thing. If the resultant of the forces applied in a particular rigid body is 0, the body is in static equilibrium, and if the resultant is not 0, the body is in dynamics with some acceleration. Now let's look into the theorem of static equilibrium, which will be helpful in finding the resultant forces, which is Lamy's theorem. Now in statics, Lamy's theorem is related to the magnitude of 3 coplanar, concurrent and non-collinear forces, which keeps an object in static equilibrium. Suppose that there are 3 forces A, B, C which are coplanar and concurrent and non-collinear forces. Now this is being applied in a rigid body and the angles are being represented over here. So, alpha represent the angle which is opposite to the forces which is applied as A. The beta represent the angle which is opposite to the force applied as B, and gamma represent the angle which is opposite to the forces applied as C. So using Lamy's theorem, we can state that the ratio of the forces applied to the angle opposite to the corresponding forces are equal, which means that A upon the angle opposite to the forces A, that is alpha, that is A upon sine alpha will be equal to B upon sine beta will be equal to C upon sine gamma. Now using this theorem we can find if a body is in static equilibrium, we can find the resultant of the forces based on this. Now let's look into the third thing, which is the vectors and its addition law. If a vector is being represented by two adjacent sides of a parallelogram, here in figure we can see that the two vectors P and Q are being represented by two adjacent sides of the parallelogram. Then the diagonal of the parallelogram will represent the resultant force. Similarly, if the two forces P and Q are being represented by the two sides of a triangle in the same order, the resultant will be equal to the third side in the opposite order. So these two theorems can be helpful in finding the vectors addition and the resultant of the vectors. Now this could be stated like the resultant force is equal to the square root of two forces P and Q, that is P square plus Q square minus 2PQ cos gamma. Now using this formula we can find the resultant of two forces. In this slide we will be understanding that what a free body diagram is and how it will help us out in solving a mechanical problem. So let's start with the definition of a free body diagram. Free body diagram is a graphical illustration used to visualize the applied forces, moments and resulting reactions on a body in a given condition. It helps in solving a mechanical problem since it helps in visualizing all the forces acting on the single objects and in which direction the system is accelerating. Now let's try to understand that how we are going to draw a free body diagram. To draw a free body diagram, we need to isolate the body from the system and we need to represent all the forces in that particular body. Let's take example over here that a car is being inclined in a plane. The car is being rested in an inclined plane. Now what are the forces which are being applied which are being applied in this car are, the first one is the weight of the car, that is mg, which is inclined towards downward. Now there is a normal reaction force Fn by the ground, which is being represented by the arrow. Now there is the component of mg towards the inclined plane could be represented by mg sin theta and mg cos theta. Now this is a representation of a free body diagram of a car resting on an inclined plane. Now let's try to understand that how a free body diagram will help us in solving a mechanical problem. It's like when a system or a body is in a static position, the component of the forces will sums up to 0, which means that all the components of a forces in the will be equal to 0. And the second case will be like when the system is in acceleration, so it will have an acceleration towards the direction of the resultant forces. So what we need to do is to form equations and resolve forces in various components given, and by forming equations we can obtain the desired force component. So in this way we will be able to solve a question by forming an equation, and in some of the placement interviews this has been asked to draw a free body diagram of a given system or an object. So I hope. Now let's try to understand the rotatory motion in terms of moment of a couple, rigid body equilibrium, what is moment of inertia, and how it is helpful in the rotation of the body. Let's try to understand moment of couple. See, when two forces, let's assume F and negative F having the same magnitude but opposite direction, which is parallel lines of action and opposite sense, are said to form a couple. Its effect is to create rotation without translation, without accelerating in the center of the mass. And moment of couple is defined as the product of the either of the forces by the perpendicular distance between the line of action of these forces. Here we can see that these two forces are represented as F and negative F. Now the moment of couple is R cross F, where R is the distance between the line of forces given. Now let's try to understand the moment of couple in terms of rigid body equilibrium. See, a body is said to be in equilibrium, that is, for a rigid body in static equilibrium, the external forces and the moment are need to be balanced and will impart no translatory or rotatory motion to the body, which means that the necessary and the sufficient condition for the static equilibrium of a body are that the resultant force and couple from all the external forces from a system that needs equivalent to zero. That is, all the moment of summation of all the moment of couples or the resultant forces that has to be equal to zero, and that is the necessary and the sufficient condition for a rigid body equilibrium. Now, for a body to be in a rigid body equilibrium, we need to resolve each forces and moments into its rectangular components, and we need to express the condition for the static equilibrium. Now, let's try to understand the concept of moment of inertia. It is basically the rotating body's resistance to angular acceleration and is equal to the product of the mass and the square of the perpendicular distance from the axis. It is sometimes also referred as the angular mass, and it is inertia of a rotating body with respect to its rotation. Now we will try to understand that how we will be able to find out the moment of inertia of a particle and a body. For a particle, the moment of inertia could be easily calculated by obtaining the product of the mass and the square of the perpendicular distance from the axis. Now let's try to find out that how we can obtain the moment of inertia of rigid body. See, in the figure, it is like we need to find out the moment of inertia of a rigid body. In that case, this could be defined as the sum of the second moment of area of individual section about an axis. We need to find out the moment of that particular particle, and we need to integrate it to obtain the moment of inertia of the whole body. Let's try to understand this. Let A1, A2 and A3 are the small elements area, which is the sub area of the total area given. Now we can obtain the total moment of all the areas about the x-axis, and we can obtain the total moment of area on the y-axis, and we need to find it, sum it up to obtain the area moment of inertia of the given figure. In this way we can find out the area of the moment of inertia of a given shape or a body, and that will help us in finding the. Now in this slide we will try to understand the kinematics of the rigid body. The type of the motion of a rigid body can be classified in two types. The first one is translatory motion and the second one is the rotatory motion. Now students, it's often asked in placement interviews how to solve the questions which is based on the translatory or rotatory motion. So we will be understanding the equations involving in these particular types of motions and how to apply those equations to solve a numerical. Now let's try to understand the new translation motion. It is a kind of motion in which all the particles forming the body travels along a parallel path. Also, the orientation of the body does not change during the motion. So basically, all the particles of a body moves in a parallel path in a straight line. So translatory motions can be classified in two types. The first one is rectilinear, in which the motion of a body in a straight line, and the second one is curvilinear, in which the motion of a body in a curved path. So when a body is under the translation motion and the acceleration is constant, we can apply Newton's second law, that is F is equal to force is equal to product of the mass and acceleration to find the resultant forces, or sometimes acceleration or mass. Or we can use the equations like v is equal to u plus at, s is equal to ut plus half at square, where s is the distance traveled by the particle, u is the initial speed, a is the acceleration, and t is the time taken. We can also apply the equation v square is equal to u square plus 2s to find the velocity, acceleration, the initial velocity, or the time taken by the body to travel a certain distance. Now let's try to understand the rotatory motion of a body, that is rotation of a body about a fixed axis. In this kind of motion, all the particles forming the body travels along a circular path of different radii around a common center. Now this particular common center is sometimes referred as the center of the rotation, and axis perpendicular to the plane of the body and passing through this particular center of rotation is sometimes referred as axis of rotation. And since we know that the axis of the rotation remains constant, that's why this kind of motion is referred as rotation of a body about a particular axis. So here we won't be using the terms linear velocity or linear acceleration, but here we will be using the terms angular velocity or angular acceleration. Now we can easily establish a relationship between linear velocity and angular velocity. Now let's look into the figure and consider a body rotating about a fixed axis passing through a point O. At a given instant, the angular velocity of a body is given as represented as omega. Now all the particles present in the body will rotate, which will have a same angular velocity, but of course a different linear velocity. If Vp is the linear velocity of a particle P and its distance from the axis is represented as Rp, the radial distance, which is the radial distance, then we can represent the linear velocity Vp is equal to Rp, which is the radial distance, and product of angular velocity, that is V is equal to R omega, which we can establish, which will help to establish the relationship between the linear velocity and the angular velocity. Now in the same way, we can establish the relationship between linear acceleration and angular acceleration. Let's consider a body rotating about a fixed axis passing through O, having an angular velocity omega and angular acceleration alpha at the given instant as shown in the figure. Now we know that if a particle is in a curvilinear motion and it's in a circular motion, it has an acceleration which can be further resolved in two components. The first one is the normal component and the second one is the tangential component. We can obtain the normal component of the acceleration and the tangential component of the acceleration, and the total acceleration can be obtained by summing up these two components. Now these are the equations which we can apply in solving a question based on rigid body motion. Now we need to understand that in most of the placement interviews, the focus is on the conceptual clarity and practical application based question rather than that of the theoretical concepts. So we need to prepare ourselves accordingly. Thank you.